So, students, is nature really random? That's the essential question that we need to answer today. Because today's lesson is our supplemental lesson in preparation for our assessment. Okay? So, for us to answer the question, let us observe the human body. When you see your human body, is there any pattern sa katawan mo? Okay? So, how about the plants, the flowers, the rabbits, and honeybees? You know what? These are the things we need to talk about. To answer the question, is nature really random? Okay? So, here are the four key ideas of our lesson today. So, the four key ideas is defining the sequence first. So, sequence is a number following a specific rule or pattern. Also, a type of sequence that we need to discuss today is the Fibonacci sequence. It is each term is the sum of the two preceding terms. When we say preceding terms, these are the previous and the second previous term. Also, we have the recursive rule. So when we say recursive rule, um, it is the way in using the previous term. And also, we have the golden ratio. The golden ratio has a value. A value of golden ratio is 1.618 in three decimal places. But you have to use, it will depend whether kung ano man ang gagamitin natin Fibonacci's number or hanapin natin, it will depend sa kung ilan yung gagamitin natin decimal. Okay? So, we all know that the Fibonacci's number will start with, of course, the first term, 1. Then we're gonna add that to the next term for us to get the next term. Because yung 1, bago yan, merong 0, di ba? 0 plus 1 is 1. For us to find the third term, we're gonna add these two number. We have 2. That the fourth term, 1 plus 2 is 3. The fifth term and eighth term, ganun lang din yung pattern natin para makuha natin yung susunod na term. We're gonna add the previous and the second previous term. Okay? So that's the Fibonacci sequence. So I know when you see these things, if you want to complete it, the missing number is for us to find that, we're gonna add 5 and 8. That is going to be 13, right? Then 13 plus 8, that is going to be 21. So that's the basic rule for us to complete this pattern. Okay, so the missing two numbers here are 13 and 21 by adding the previous and the second previous term. Now, let's talk about recursive rule because there's a rule for that. The x of n must be the nth term. Yan yung hahanapin natin. And then the n sub n minus 1, that would be the previous term. And the second previous term would be x of n minus 2. Okay? So for example, you have the x of 7. The previous term is x of 6. Why? Because 7 minus 1, that is 6. Okay? Then the second previous term is 7 minus 2, that is going to be 5. Okay? So from the Fibonacci numbers, we have 1, the first term, 1, 2, 3, 5, 7. No, it's 7, it's 8 because 3 plus 5 is 8. Then 5 plus 3, that is going to be 13. Okay? So let's find out what is the x of 6. This is x of 1, x of 2, x of 3, x of 4, the fifth term, the sixth term. Okay? So for us to find the seventh term, we use the 8 as our sixth term. 8. And then the previous term is 5. 8 plus 5, that is going to be 13. So the seventh term is going to be 13. Seventh term. So that's it. That's how we use the recursive rule. Now, for us to try the concept from the previous discussion, let us find out the 29th term. But here's the catch. You're going to use this sequence. Okay? The previous term of 29th term is 28th term. And that is equal to 317,811. And the second previous term is 196418. That is 27. What you're going to do is to find the 29th term. For us to find the 29th term, you must add this two previous term. So we have 28th term, that is going to be 317,811. and then we're gonna add that to 196,418. For us to add, you can use calculator, but the sum would be the 29th term, 514,229. That's how easy it is. Just add the two previous term, the previous term and the second previous term. Okay? So, from numbers to spirals, for us to appreciate the Fibonacci sequence, it all start with one square, okay? Another one square. Then when you add the two little square, you gotta have two squares. I mean, two unit square, much bigger than the smaller square. And then three, then five, 8, 13, and the sequence will go on forever. And I want you to appreciate the spiral that we created here. So we have this Fibonacci numbers, and you know what? These are the examples of the spirals, the same as the spirals in Fibonacci number. If you see the snails, one of the examples is snails, ocean waves, whirlpools, storm formation, galaxies, and architectural designs. So these are the real life example of the Fibonacci spirals. Okay? So now, what about in nature? When you see the tree branching pattern here, so I want you to observe this one. So there is they are using a Fibonacci number as well. For example, when you divide the tree into equal parts, you may see here that we have that we can see here that we have our wait, and so the first number, the trunks, only one. Okay, also the second part, we have one as well. Okay, this part is one, and eventually when the tree grows, it will produce two. Okay, meron na tayong three na branches din. Then 5 branches, 8 branches, and 13. So basically speaking, they follow a Fibonacci number. So how about the petal ng mga flowers? So as you can see, I have here the flower. Kung bibilangin natin ng mga petal niyan, meron tayo 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. Basically speaking, they are following a Fibonacci numbers as well. Okay, so that's the thing that we need to look for. So Fibonacci numbers can appear in growth patterns in nature. So what about the rabbit population? If you still remember the history of the the Fibonacci numbers, it comes from the idea of Leonardo of Pisa. He observed the rabbits, assuming na hindi namamatay yung rabbits, what will happen then sa reproduction nun. So napansin niya na ganito yung pagdami ng rabbits in each generation. So bawat generation, first, of course, naglagay lang siya ng one pair doon, na-observe niya. Yung pangalawang generation, one pair lang din. Pangatlo, we have two pairs. Pang-apat, naging three na yung pairs natin. And then panlima, we have five. Sixth generation is 8. And as you can see, the patterns of reproduction of rabbits continuous, but the numbers is very familiar. And that was the starting point of the Fibonacci numbers. Okay, so you know what? The idea is each pair of rabbits produces a new pair once they mature. The pattern of total pairs follows the Fibonacci sequence. Okay, so even honeybee family, they are using a generation patterns of Fibonacci sequence as well. Um, Also the Pascal triangle, if you get to see this one, yung diagonal part niya, this is 1. Also meron tayong 1 dito. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 plus 1 is 5. 1 plus 4 plus 3 is 8. And they are following a Fibonacci rule or number as well. Okay, so here we have the golden ratio. So for us to find the golden ratio, we have to divide each higher Fibonacci number by its preceding number. Bakit kaya mahalaga ang Fibonacci number sa golden ratio? Let's see. What will be the thing what will happen if meron tayong mga mas malalaking version ng Fibonacci number tapos kinuha natin yung o dinivide natin yung malaki dun sa preceding number niya. So, again, we will let A as preceding number, higher naman yung B. So, ang gagawin natin, basic formula lang, i-divide natin yung higher sa preceding. Okay? So, if you have the preceding number na 317,811 at yung higher number niya is yung mas malaki, 514229, i-divide natin yan using calculator. The answer must be equal to 1.61803. Okay? Same with the other one. We have 196,418. Yan yung preceding number niya. Tapos yung mas malaking number niya is 317,118. Divide natin yung 317,811 pala. Divided by 196,418. The answer must be the same. Same with other Fibonacci numbers. The answer is always lead to one value. That is approximately 1.61803. Ano bang tawag dito sa 1.61803? Ang tawag dyan is the golden ratio. So, ang golden ratio, this is the symbol that we need to use. So, as number increases, yung B over A natin, it will lead to 1.618. Okay? So, now, the golden ratio in human proportion. Tignan natin kung pwede. Alam nyo ba yung human arm ninyo? Kapag kinuha nyo daw yung measurement nito from wrist to this part, that would be the much bigger measurement. Tapos, dinivide mo po dito sa measurement naman ng from wrist to your to the tip of your finger here. The answer must be approximately the golden ratio. Okay? Also, the human height from navel hanggang sa eye level, tapos sa baba, it also answers the human ratio. Okay? I mean the golden ratio. So, they are following the golden ratio as well. Also, the golden angle calculation. If you have this planned, di ba? So, these are the golden angles, 222.5 and 137.5. Kapag ang given natin ay 137.5 lang, yun yung x natin, ang formula na gagamitin natin is the golden ratio equals 360, yung kabuuang revolution niya, minus x over x. Yung x natin is the 137.5. So, substitute natin, the golden ratio is equal to 360 minus 137.5 divided by 137.5. What would be the result? 222.5 yung result sa numerator divided by 137.5. Ito na yung 222.5. The answer must be the golden ratio, 1.618 approximately. So therefore, 137.5 will lead to the golden ratio. So 137.5 is the golden angle as well. Okay? And then 222.5 is the remaining angle. So, ngayon, ang gagawin natin, since alam naman natin ang golden ratio, yung mga bagay na yan, we can see the golden ratio and also in the plants. Okay? So what else? The Fibonacci spirals in plants naman. Let's have the sunflower, pine cone, and the spiral plants. And as you can see, may mga spiral yan kung titingnan mo naman mabuti yung gitna and yung pine cone, yung sunflower, yung spiral leaves. Yung dito sa sunflower, yung clockwise na spiral niya, that is 8. And then counterclockwise niya is 13. So what does it mean? Ang ibig sabihin lang nun, these two numbers are an example of Fibonacci number, and that would lead us to the golden ratio as well. Pine cone and the pine cone. We have 8 and 13 as well. Spiral leaves as well. Okay? So, Fibonacci spirals in plants, we can see a Fibonacci numbers and golden ratio. Okay? So, also, ano pa? Saan pa natin pwedeng gamitin o makita itong golden ratio? Sa ngipin natin. So, yung ratio nitong part na to at yung ratio ng part na to ay equal lang din or mag-lead sa 1.618. Also, in our DNA structure, the ratio of length to width is approximately 1.618. Okay? So, that's it. Those are the things. These are the things na makita natin in real scenario. So to answer the question, is nature really random? I think to answer the question, that is not. Okay? Hindi po random ang nature natin because it has a pattern. So, now let's talk about the Binet's formula. So, what if pinahanap ko sa inyo yung 99 term? Ano po yung pinaka pwede mong gawin para mabilis nyo pong mahanap without using recursive rule? Kasi pag ginamit mo po yung recursive rule, baka matagalan ka. Okay? So, ngayon, we have this given formula, x of n equals 1 plus the square root of 5 over 2. You can type it in your calculator. Tignan nyo kung yung result mamaya. Raised to n minus 1 minus square root of 5 over 2 raised to n divided by square root of 5. Now, the n is the term number and the x of n, yan yung n Fibonacci term na hanapin po natin. So you know what? This golden ratio is equal to this number 1 plus square root of 5 over 2. And that would lead us to 1.618. So ibig sabihin, golden ratio pala itong part na to. So the formula can be written using the symbol for the golden ratio. Para mas madali natin maintindihan, ganito po natin siya ilalagay. Okay, so this is the formula that we need to use later on. So now, let's find out the x of 11. So the Fibonacci number is, once again, para mahanap natin yung 11 term, we're gonna use this formula. So the golden ratio here is 1.618 lang muna, and then square root of 5, 2.236. So since 11 term pa lang naman, mababa lang yan. Okay lang gumamit ka ng mga 3, 5 decimal. Pero sabi ko sa inyo, kapag umabot na ng 30 or 30 plus or 20 plus, gamitin mo na lahat ng decimal number para mas legit yung magiging sagot po ninyo. Okay? Substitute lang natin. The 11th term is equal to 1.618. Yan ang golden ratio kanina. Raised to n. Ang n natin is the 11th term. Minus the 1. Minus the golden ratio, 1.618. Raised to 11 pa rin. Kasi 11 term ang hanapin natin. Divided by the square root of 5, 2.236. Ngayon, type mo sa calculator to, the answer must be 198.959. Yung 1.618 raised to 11 minus 1 minus 1.618. Yung loob muna, tapos i-raise mo sa 11 para makuha mo po itong negative 0.00502. Okay? Sometimes, ang lumalabas is naka-scientific notation siya pag yung tinype mo sa calculator. Ang gawin mo, kung naka times 10 raised to negative 3 siya, mag-move ka ng decimal point ng 3 beses papunta sa left kung negative yung exponent niya. So, dito, ito na po yung ginamit ko po. So that's why the result of subtraction ng 1 minus 1.618 tas ni-raise ko pa sa 11 ay negative 0.00502 divided by 2.236. So ngayon, subtract natin ng taas. 198.959. Of course, ito po, yung negative times negative, that is going to be positive. So plus na po yung magiging operation natin. So 198.959 plus negative plus, hindi na siya negative, 0.00502, that is equal to 198.964. Divide ko yan sa 2.236, the answer must equivalent to approximately 88.98. So kapag ni-round off natin yan, ang term 11 natin is 989. Again, bakit siya nakuha ng tama? Dahil mas maliit pa lang yung number na ginagamit natin. Again, kapag mas malaking term na ang hinahanap natin, kagaya nito, 31, gamitin mo na lahat ng decimal number sa golden ratio. Okay? O, sige po, ito muna. Try ko lang po muna ito. Para mahanap yung 31st term using the Binet's formula, ganun din po, gagamitin ko po lahat ng mga decimal, the-raise ko po sa 31 yan, minus 1, minus yung lahat ng decimal, raised to 31 ulit, square root of 5. Okay? Then, erase ko na po yung itong part na to. As you can see, medyo malaki na yung version niya. Then, minus negative or 1 minus this golden ratio, mas maraming zero kasi naka-raise na sa 31 yan. Di ba? And then, divided by square root of 5. Tapos, ganun din. Add mo lang ulit to kasi parehas negative. So, plus. Tapos divide mo sa 2.23606,798. The answer must be 1,346,269.29. So, the 31st term is approximately 1,346,269. Okay? Again, kulang pa to eh. Dapat nga mas kompleto pa. Pag tinype mo yung golden ratio, pag hinanap mo yung golden ratio sa calculator using the formula, lahat ng mga numbers doon gamitin mo. Okay? Para mas maging legit yung magiging sagot mo. So, try nyo nga. Can you find the 25th term? Practice lang. No? How about 30th term? What is the golden ratio? What is the golden angle? Okay? So, these are the things that we need to answer, verify, kasi may mga sagot na ako dito. No? For review na lang. Thus, after nito, I'm gonna give you the assessment. I will send it to in our GC. Okay? So, I hope you understand this lesson. I believe this is the last part. Thank you for listening. See you in our classroom.